integration by substitution. It is essentially the reverse chain rule, transforming a complicated function into a simpler one in terms of another variable. So let's have a look at the basic integration with the reverse chain rule. So for example, integration of the cos 3x of dx. We know integration of the cos is sine, so we have sine of 3x. And we have to divide it by the differentiation of the inside function, which is 3x. Differentiation of 3x is 3, so divide by 3 plus c. So this is a very basic integration with reverse chain rule. Sometimes the integral is not basic enough to be integrated, then we should try integration by substitution. But often you will see there's another function. So there are maybe a few different functions multiplied together or divided by each other. However, one of them, if you differentiate it, it will lead to another. So for example, if I differentiate 3x squared plus 1, that will give me 6x. So the power of x is actually same as 18x power. So this is probably a hint for you to use the integration by substitution. So let's see how we're going to do it. So firstly, we're going to choose another variable. Let u be the one that can be differentiated and leads to the similar type of another function inside. Therefore, we're going to differentiate it. So du on dx is 6x. Now we're going to replace it, the original one, with u. So it's 18x times by u squared. Now, you notice that we start to introduce a new letter. We want to actually make everything in terms of u instead of x. So that means I can't really have dx. So what we're going to do is we're going to use this part here. So we have to do one more thing. We're going to rearrange it. So we have du over 6x equals to dx. So now we're going to replace the dx in the original question with du on 6x. Now you notice that by doing this, we can actually simplify further, and x can be cancelled. And obviously, we have 6 and 18 can be cancelled as well. So we have this one is 3. So that will give us integration of 3u squared du. Now the whole integration is in terms of u. And that's great. And it's a lot easier to integrate it now. So all we need to do is 3u add 1 to the existing power divided by the new power plus c. So that will give us u to the power of 3 plus c. Now, the original question is in terms of x. So we have to sub the u back with what we have. So therefore it is bracket 3x squared plus 1 to the power of 3 plus c. Now what I would love you to do is to try this question by yourself and then check the answer. Now let's have a look at this example here. Observe the question first. So you have two functions multiplied together. And in the bracket, I have 3 plus x squared. And I know that when I differentiate it, that will give me 2x. So which is the same type of function as 20x. So we're going to choose this one as our u. So let u equals to 3 plus x squared. We're gonna do two things here. So du on dx is 2x, and rearrange it so that we know what dx is. So it's du on 2x equals to dx. Now we have done the main job here. So all we need to do is do a substitution into the original function. So we have 20x, and whatever's in the bracket is represented by u to the power of 5, and dx is replaced by du on 2x. Now you notice that we can actually simplify this, will give me 10. So therefore we have integration of 10u to the power of 5 du. Everything is in terms of u, which is good, and we're going to integrate it. So we have 10u to the power of 6 on 6 plus c. So simplify further. Now at the end, you must sub du equals 3 plus x squared back. So we have 5 on 3, bracket 3 plus x squared to the power of 6 plus c. Now please pause the video here and try these two questions by yourself and come back to check the answer. So example 3, let's observe the question. We have 2x plus 3 in the bracket. If I differentiate this, that will give me 2, which is like constant number, which is same type as 12. It's another constant number. So we're going to let u be 2x plus 3. Differentiate it, du on dx is 2. Again, rearrange it, so I know what dx is. So du on 2 is my dx. Now we are going to do a substitution. So I have 12 times by u to the power 4. Replace the dx with du on 2. And we can simplify it. So that's 6. So I have 6u to the power 4 du. All I need to do now is integrate it. So I have 6u to the power 5 divided by 5 plus c. Now I need to replace a u with 2x plus 3. So I have 6 on 5. You have 2x plus 3 to the power 5 plus c. Example 4, you have ax times by e to the power of x squared. But you're going to ask yourself, what can I differentiate and get something else that's similar, has similar look? So if you look at it, if I choose u be x squared, when I differentiate it, that will give me 2x, which is similar type of function as ax. Great, we're going to leave it as it is. So now we're going to rearrange it so know what dx is. So we have du on 2x will give me dx. Now it's time to do the substitution. So I have ax times by e to the power of u. Replace the dx with du on 2x. Great, I can simplify further and my 2x is gone and ax become 4. So that will give me integration of 4e to the power of u du. We can integrate exponential function easily, so that will give me 4e to the power of u plus c. Now I just need to replace a u back with x squared. So I have 4e to the power of x squared plus c. Example 5. So I have integration of 3 cos x times by sine square of x. Now usually I will start with something has power. So let u be sine x. So you just want to check whether when you differentiate you can actually get the look of another expression of function that's actually inside the integration. So I have du on dx equals to cos x. That's a really good sign. That means I actually potentially can actually simplify and get rid of cosine x. So therefore my du on cos x is my dx. Let's do a substitution and see whether that works. So I have this times by u squared, and dx is my du on cos x. Perfect. I can simplify it. So my cos x is gone. So I have 3u squared du, and this is very easy to integrate. So you have 3u cubed over 3 plus c, and cancel it again. So now replace u with sine x. So you have sine x cubed plus c. This time we have rational functions. What that means is we have something divided by something. Instead of product, we have quotient here. So let's observe. Is there something that I can differentiate and give me the look of another inside the integration? The answer is yes. If I integrate 2x squared minus 3, that will give me 4x, which is same as the numerator. So we're going to let u be 2x squared minus 3. Du on dx is 4x. So therefore my dx is du on 4x. Now all I need to do is substitution. So therefore this is 4x over u, and my dx is du on 4x. Now you can see clearly, I can simplify, and that will give me 1 over u du. Now remember the integration 1 over u is actually natural log of absolute value of u plus c, and we're going to replace the u with 2x squared minus 3 plus c. We can do the same thing for the next one. If you look at it, if I differentiate the bottom one, that will give me a similar look to the top one. So I'm going to let u equals to 3e to the power of x minus 10. So du on dx is 3e to the power of x. And my dx is du on 3e to the power of x. Now all I need to do is the substitution. So we're going to replace it. So the bottom one is u, and my dx is du on 3e to the power of x. And you can see that e to the power of x is cancelled. And what we have here is now 1/3 times by 1 over u du. So it's 1/3 ln absolute value of u plus c. Now again, you're going to replace the u with what you have set up in the beginning and plus c.